Hi, this is Professor Cummings, and I wanted to do a presentation where I go over the basic definition and the overall vision behind this new concept called Industry 4.0. Now, I'm saying new concept, not so much because the idea behind what industrial Industry 4.0 stands for is new in and of itself. It's just that if you were to do any type of literature search, you're going to be hard pressed to find the term Industry 4.0 or Fourth Industrial Revolution going more than 5 or 4 years back. So it is a relatively new concept, even though the ideas that built up to Industry 4.0 are actually quite logical and not very old or unforeseeable at all. So before we go into Industry 4.0, which is just talking about the fourth industrial revolution, let's give an overall definition of what an industrial revolution is. So what is an industrial revolution? So just it's the transition from one manufacturing state to another. And it's driven by changes in technology, culture, and policy. And that's key here, technology, culture, and policy. If we look at all the industrial evolutions in the past, going from the first, second, and third industrial revolution, they all had those three things in common to some degree or another. So some of the drivers, again, obsolete, some skills that were obsoleted, and then there were some skills that were required that were brought on by each one of those industrial revolutions. So again, you represent that as the technology that was one of the drivers, culture, and then some of the policies. So they either had skills that got obsoleted because of what was going on in the revolution actually made it so that these skills no longer were required, labor saving devices, safety requirements, quality requirements, certain types of things were no longer required or being diminished. Again, obsoleted doesn't necessarily mean eliminated. It just means that they're no longer as big of a player on the field as they were in the past. But along with that, there are new skills that are required. They might not be as upfront. It might be in the foreground. They may actually be more in the background. But the industrial revolution of any kind always brings about some demand for new types of skills. So let's look at some of these industrial revolutions. So the first industrial revolution, it's recognized to have started around the 1760s. It might be a specific year depending on where you look it up, and it was really marked by mechanization. So this is the start of steam power, water power, being able to harness those and use them to actually perform some kind of work. Then there was the second industrial revolution, probably the one that most people think of when they hear the term industrial revolution. Something a combination between these two, but definitely a lot of the advances that took place in this second industrial revolution were the ones that really strike people the most. This was when electricity was being harnessed. This is when the concept of mass production was being put into place, as well as ideas such as material sciences were being developed. So there was a lot of things that happened in this second industrial revolution that really mark things that we are take for granted today that really have shaped the world as we know it that didn't exist before this period of time. And we can look at that and attribute that to the 1870s. And there's a third industrial revolution. Now, as you go back and if you were trying to do your own research on this one, what I found in my research is that this third industrial revolution is a little bit fuzzy. It's clear if we follow the definition of industrial revolutions that this is one of the biggest markers of the third industrial revolution. But you can find, a lot of literature that will argue that we are currently going through a third industrial revolution right now. And then there's the fourth industrial revolution, and that's the cyber physical systems. That's where we actually are integrating more of our computer technology as well as our globalization, as well as cloud-based technology, and creating a more interoperational systems, more standardizations, a whole lot more integration between the technologies and human interaction now. So what is Industry 4.0? So I want to start here, start at the end here. I'm going to go back, go through a little bit more on how we got here, and then finally round up with some of the vision of Industry 4.0. So Industry 4.0, cyber physical systems. It's the integration of computation, networking, and physical processes. And this is according to a really good website called cyberphysicalsystems.org. That's an organization out in Berkeley, California, where a lot of smart people are doing a lot of developing on, cyber physical systems. So a lot of good information on that site. Again, it's the integration of computation, networking, and physical processes. So you've got a physical act that you're trying to use. You're using computer and automation to help, as well as some sort of networking control to be able to utilize this system. And that is really one of the key parts of Industry 4.0. It's this whole idea of the ability to create a network and some sort of a system that helps control, manage, and dictate your output. So this is a little schematic, a little just flow chart to so what Industry 4.0 kind of looks like if you had to conceptualize it. So you have here some sort of physical act, some sort of physical part. So this, you could think of this as your machine that's actually producing your component that you're trying to create and sell. You have some sort of interface and some sort of network. So some sort of system that's actually controlling everything. Your physical part has sensors that connect to the interface, sends information to the network, and your network gives some sort of feedback and causes some sort of adjustment to the physical system. And that's the whole idea of Industry 4.0. So as you can see, there's a lot more interaction, a lot more interfacing between major systems, as well as a lot more remote control and automation in this type of a system. Now, let's go back to Industry 4.0. I want to try and tie together these different types of industrial revolutions and how we got to where we're at today and why this vision of Industry 4.0 is so important. So again, going back to the first industrial revolution, that was marked as a mechanization. So it was utilizing of steam as well as water power in order to uh, actually advance industry. So if we were to go back to this, again, remember it was attributed to the 1760s. But before then, uh, an inventor, an engineer named Savory, invented the first commercial steam engine. An atmospheric engine that was operated by steam, and it was used to pump water out of mines. So if a mine was being dug, if a mine was being dug, it would oftentimes fill up with water, and they'd have to come up with some sort of way of getting the water out of the mine so they could progress, into their work. So Savory came up with a method, a steam engine that could actually pump the water out of the mine. Now, Newcomen came to an idea, improved upon this engine, and came up with another atmospheric steam engine that was more efficient. And he was actually able to sell this throughout parts of Europe as a way of helping out other mining industries. So he actually started to commercialize this improved version of the atmospheric steam engine. Now, this was actually on the market for several years, several decades. That and Newcomen actually died a wealthy man because of this invention, commercializing that invention. Now, then there was another improvement by a name you might find familiar, James Watt. And yes, that is the person why we have the power system called the Watt, the power unit of power. That was in 1778. He took his version of the steam engine and he used it for industrialization purposes, and he applied it across several industries. The textile industry, the paper industry, cotton, flour, iron industry. So he really did. He partnered with a lot of different engineers and built up this industry utilizing this steam engine. It was much more efficient than all of its predecessors, and again, a lot of money was made, a lot of things that were able to help out different industries, and going global with this particular design. Now, almost at that same time, you can see it was actually 9 years before, Richard Arkwright came up with a system, around water power. He developed something called the water frame. What the water frame used was it actually used the power of a water wheel to industrialize textiles. So now this system was able to replace several people and able to develop cloth and able to develop threading, take cotton and turn it into a useful type of material, so that the textile industry could get mechanized and put in under a lot more competitive production. So what essentially was doing going on here is we start off with a craftsman system. Okay, now the craftsman system was essentially people who actually, like the name implies, developed a craft, whether it was in textiles, whether it was in metalworking. These people had a craft that they developed. They became very good at it, very skilled. They went through an apprentice program. And what they did was they developed this system that they manufactured. Now, with the advent of this, the first industrial revolution was we were able to develop something called the factory system. Now, this is a very big simplification, but these technologies, the steam engine, the water frame, steam and water power, were part of the reason we were able to go from this one person performing a highly skilled task to a highly industrialized uh, version of that same work. So we went from some one person working on a loom to an entire industrialization of a mill where several people were able to work on a loom or several different looms operating and taking the place of just one individual. And the same goes for other types of industrialization. We're able to use one engine as one power source so that several people or several different type of operations could take place with a lot less people interacting involved. And this whole system, both of these systems, depended on a technology known as the line shaft. All the line shaft is just a transmission system that allowed for industrialization. So this was the start of building a lot of factories, or just factories, in order to house a lot of different operations all at once. So we went from a craftsman system with one very skilled person performing one act at a time, performing one job at a time, to a lot of people where the skill level wasn't quite as high. You didn't necessarily need a craftsman. What you needed was people who could monitor these machines, make sure things didn't go wrong, put them back together, make sure that, if they had to change something in production, that it could be changed. So you needed, a lot less skill and a lot more warm bodies in order to run things. So this the first industrial revolution. It was driven by steam and water. It was mostly also driven by trade. Bigger commercialization, more people wanting their resources. But it was also the development of environmental laws, as well as trade unions and craftsmen guilds. So then this was one of the two of the side effects or the drivers of it. So when you've got this bigger industrialization, you do have to deal with a lot more quality issues. The guilds used to give a stamp of approval. Now you've got trade unions, a lot of people working that needed to actually have certain type of protections, sort of standardization with how the labor was actually treated. So some of the skills that were being obsoleted were craftsmen. So those guys weren't as much in demand if you could get a certain standard quality of product from people who are a lot less skilled. Also, agriculture was becoming more obsoleted. But some of the skills that were actually starting to be required was, people who could work in these new factories. So a lot of these were people who had formerly been in agriculture, and as well as the need for quality control. So this was in the factory system. This was our first look into quality control systems. So methods of being able to verify the quality of a product as it came off the line. Now then we have the second industrial revolution. Now this was like 90 years later, roughly 90 years later, and it involved a lot of things, but it's noted by electricity and mass production. What we have here is not all of them, but quite a few people who were heavily involved in that second industrial revolution. So some of you may recognize, some not. So you got Thomas Edison, Elijah McCoy, you got Nikola Tesla, you got Westinghouse, and some of the things that were developed. Again, the light bulb, the internal combustion engine, uh, telegraphs and telephones were actually developed by Alexander Graham Bell, and then Goodyear, as well as vulcanization of rubber. So a lot of things were developed during the second industrial revolution. So the electricity was became much more commonplace. It went from being a novel to something that during this revolution to something that was actually integrated into people's households. A lot of the engineering that took place in the railroad industry made it much more efficient, was able to make it a lot more widespread. And then you've got Westinghouse, who also did a lot of commercialization with electricity, with power stations, and a lot of development in new materials. So the vulcanization of rubber was just one aspect of material being able to be developed and also help advance technology. But beyond rubber, it was also a lot of different alloys of metal. So we went from a lot of iron to steel, which was a major driver of technology and industrialization during the second industrial revolution. Simply because steel is a lot tougher, it was cheaper, it could be processed a lot more effectively than cast iron could. So it, again, really was a major player in the second industrial revolution. But one of the things that people note when they think of the second industrial revolution is this date here, the time period in the early 1900s when Henry Ford introduced the moving assembly line. This was a major part of industrialization and being able to run factories, being able to have interchangeable parts, as well as helping out quality. And it also was because of a lot of things that were going on during this time period and some of the other things that marked this second industrial revolution. It just completely changed the way of life around the world. There was issues with helping eliminate child labor, the whole concept of the 40-hour work week and the weekend, the rise of the middle class, you know, better communication. Again, that's not so much with Henry Ford as it is with the fact that we had different technologies now. And again, advanced alloys. Manufacturing became a lot more efficient because we had more appropriate materials that we could work with that allowed us to do a lot different things, develop a lot of new different types of tooling, as well as more efficient machine tools, which goes back to the different types of alloys, different types of cutting tools we were able to develop. So there was a lot of new development that came around because of this second industrial revolution. So to look at the things that actually impacted or drove the industrial revolution, the second one, again, you got new materials, the internal combustion engine. A lot of things were driven by the military. If you notice the time frame of the second industrial revolution, we had World War One, World War Two, the Spanish American War. We also had the biggest growth of the middle class, and then policies such as child labor laws, as well as union and worker safety laws changed in this industrial revolution. Some of the skills that were again becoming more obsolete. A lot of these are things like agriculture. The railroad system changed quite a bit, as well as nobody hears about jobs such as quarrymen. People actually go out and cut stone. So a lot of things were eliminated or just obsoleted because of this second industrial revolution. And one thing I want you to note, things that are being obsoleted, not necessarily eliminated, but definitely obsoleted, is these are all very labor intensive type jobs. Jobs where you need to be physically very strong. These aren't jobs that anyone could do. So there were definitely some physical restrictions that were downplayed because of our ability to use a lot of labor saving devices. But the skills that came up now were things such as machine operators. A lot of machine tools were developed and a lot of them helped out in mass production. People with strong mechanical skills became a lot more valuable in the second industrial revolution, as well as because of all the industrialization and the ability to create more with less, things such as foundries and welding technologies became a lot more prevalent because of the second industrial revolution. Now then we get to the third industrial revolution, which is marked by computer and automation. Now, these are what you can see when we talk about the second industrial revolution. You had factories, you got people working in large numbers, being able to make relatively, for the time, high-tech devices. But you can also notice something else that's common in these two pictures. The first one is, a factory, an actual factory of people making engines. The second one is a draft room. And all these people are engineers that are and draftsmen that are actually creating mechanical drawings for different devices, different things that are going to be made, and they need a blueprint in order to work from. The second industrial revolution brought us automation and the use of computers. So we have computer aided manufacturing and computer aided design, which is a lot faster and a lot more accurate and a lot more easily adaptable than just your typical draftsman's work. Instead of doing everything by hand, you can now go in and make very significant and even subtle changes on a computer. So these CAD systems made the ability to create drawings much, much faster, much more accurate, and much more easy to transfer from one engineer to the next. And up here, you've just got automation. Again, both of these are automotive plants of one form or another. You notice even in this, you've got a lot less robots than you have people, and they typically are doing the job more repeatably and faster. So it was bring about as the third revolution was marked as the time when we started going into automation and using computers to assist in our work. So that was the third industrial revolution. So it's automation, computerization, and it also brought about a new industry, one that never existed before. IT. The IT industry is a direct product of the third industrial revolution. I mean, this is an industry of, a whole new skill set that was required to keep this industry running. And there isn't any other type of, or excuse me, there of any of the industries you can find, they all have some interface with some sort of IT personnel, information technology. So somebody who had to manage it. So that was a whole skill set that was developed because of this third industrial revolution. Now, the fourth industrial revolution is going to be marked with things such as cloud computing, the ability to share data, the ability to be flexible, the ability to change part numbers, get information quickly between different types of manufacturers or different types of industries, being able to respond to customer demands very, very quickly. Again, these were all things that came about during the third industrial revolution. But with the fourth industrial revolution, you've also got the whole idea of a network, some sort of hub, some sort of brain, if you will, for the entire system that will allow for these things to take place. And where we are today is pretty much in the transition stage. So these are technologies that you could find if you do a literature review or literature or technology search. You'll find the concept of smart machines. Machines that can actually have some sort of sensing mechanism to where they can actually respond to feedback. Intelligent factories. The whole idea of this is the closest to the fourth industrial revolution. So the ability for a factory to change or have apps that can help control the information that goes into and out of a factory to make changes to respond to the customer. The ability to self-correct. One of the smart machine platform initiative, one of the technologies that were developed by NIST and through uh, the U.S. Army, the Department of Defense, was the ability for machines to be able to both self-monitor and correct based on different types of feedback and different types of sensors. So the idea of the ideal smart machine would be the machine being able to change due to work conditions, different types of forces, different types of pressures at the tool or anything that you're able to sense on that machine and respond to it through a series of algorithms. And so let's take all these things are taking us to that closer to that vision of the fourth industrial revolution. So having some sort of network that helps control and work as some sort of gatekeeper of all this information. So I hope that this gives you a better idea of what Industry 4.0. It's still, a fairly new idea. It's still got a lot of work to go before we can have a full idea of what our full realization of this vision of Industry 4.0. And there are a lot of skills that will be much more eliminated, but there are also a lot of skills that are going to be required in order to bring us to this vision as well as to support it once it comes into play. So with that, this is Professor Cummings. Thanks for watching. Go ahead and subscribe. I'll try to give you videos for different types of technologies. Also, if you want to go, see any more information on any of these, you can go to my Google Plus page, which is just called engineeringreference.com, or the engineer's reference. Uh, and that's on Google Plus. Then you can go and find that and click on it, and have some updates a little more regularly. Otherwise, I just have videos once a week, excuse me, sometimes twice a week, where I can update you on different engineering and manufacturing topics. All right, thanks for watching.